I want it to, there we go. Okay, so again, we talked about one real solution, two real solutions. And if we have no real solutions, that really means we have complex solutions, right? So the steps for doing this is going to be using substitution, which you should already know how to do because we did it a few weeks ago, right? The methods don't change. The only thing that changes is when we use it, okay? So we should already know how to substitute. You're going to solve one equation for y, okay? Now, the reason I have solved for y is because, again, we're not dealing with only linear functions. Linear functions are so easy and they're so great. Why is that? Well, if you look at example 1, the coefficient on both of them, or not the coefficient, the exponent on both of them is 1, right? That makes our life so much easier because 1 and 0 are my favorite numbers when it comes to math, right? They're easy to work with. If you notice right here, we have a squared, which should be telling you that we're dealing with the quadratic function, right? That is one thing that we need to make sure that we get better at if you, especially when you get into pre-cal and stuff like that, okay? Being able to identify your functions and what we have. So right here, we can see that we have a quadratic function. Now, could you solve for x? You could, but I don't want to deal with anything that isn't pretty. Okay, Miss, well, what do you mean? I don't get it. Okay, here's what I mean. So you don't have to write this down. This is me showing you why I would not want to solve for x on this one, right? Could I? Yes, you could. You could subtract 4 from both sides, so that would be y minus 4 equals negative x squared. My next step would be to divide everything by negative 1. So I would now have a negative y and a positive 4, so 4 minus y. From here, I would have to square root because you want to have the x isolated. The x isn't isolated. You technically have x times x. I don't want that. I want the x to be completely isolated, which means that the coefficient has to be 1 and the variable. So you would have to square root both sides. From here, we already know what happens when we square root, right? We talked about this a few times ago. So we know that 4 can come from 2 different places. 2 times 2 or negative 2 times negative 2. Remember when we talked about that, right? So we don't know what x that is. I don't know if that x is 2 positive numbers or 2 negative numbers, which means that I have 2 possibilities. X equals a positive square root of 4 minus y, or x equals a negative square root of 4 minus y. Remember that? This is what I mean by complicated. This is why the first step is solve one equation for y. Does that mean that you're always gonna solve for y? No, you could run into a set of equations one day in the far future when you're in college, right? Where it could be easier to solve for x. And that could happen. So I just want to make sure you understand that that can happen. It's just going to be a lot more rare because most functions are going to be easier to solve for y, right? Okay, so y equals blah. This is the one we're usually going to have, right? Or you can have x equals blah. This one, though, is going to be rare. This may never happen. You may never see it. I don't know. Anyway, so we're done with this. Y'all don't need to write that, right? I just wanted to show you why that first step is solve for y, okay? So that's why I put in parentheses, isolate a variable, because again, I'm not telling you it has to be y. I'm just saying it's probably going to be y. Now, step 2, y'all already know how to substitute. You're just gonna grab it and plug it in, solve for the remaining variable, and then plug it back in to find your answers, okay? So, example 1. Oops. Okay, so example 1. You should notice that we already have an isolated variable, right? We have this y equals negative x squared plus 4, and we have a y in the second equation. So I'm gonna go on ahead and substitute this expression in for the second one. We've done this before, so we should have an idea of how to do this. So we're gonna end up with negative x squared plus 4 parentheses, right? Because we're substituting that in, plus 4x equals 8. You should notice that now all I have left over is x's, which should look, again, familiar, right? I should already know that I'm going to have to solve for x, okay? So how are we going to do that? Okay, well, let's simplify. So we're going to have negative x squared plus 4x equals 8. What type of function does this resemble? Negative x squared plus 4x equals 8. What type of function am I dealing with right now? If I were to only look at this orange part, you should be able to identify what type of function this is similar to. Standard form of what? What type of function? We have standard form of linear, standard form of quadratic, we have standard form of several functions, okay? So you need to be able to identify this as quadratic. How do we know this is quadratic? Because of the x squared. This right here is the reason I know this is quadratic, right? It is my highest power. The highest power is a 2, quadratic. So you should be able to tell me this is quadratic. So on the side over here, I want us to remember and refresh and take into account that when I teach you how to do all of these different things, you're creating yourself a toolbox of different methods that you can use whenever you want. And it's your job to figure out when can I use them, okay? So let's look at our toolbox. This is our toolbox for solving quadratics, because that's literally what this entire unit, quadratics, has been for so far, right? Our toolbox for solving quadratics. I have taught you several methods. One of them, factoring using the X method, right? Where you find your factors, put them into parentheses, divide by A, and bottoms up, okay? The second way I've shown you, or a different method that I've given you for finding the solutions to a quadratic, is factoring by grouping. Another way was completing the square. All of these things do the exact same thing. And the last one, which was the most recent one, was a quadratic formula. This is your toolbox on how to factor and find solutions. And you're gonna be using these the entire year. So there's a reason you had a quiz specifically on factoring, because it's gonna pop up with different functions. So looking at this particular example, negative x squared plus 4x equals 0, we already know that it doesn't matter which one of these methods I choose to use, they all have to be set equal to 0, right? And they have to be in standard form. Okay, so let's go on ahead and do that. So I'm gonna subtract 8 to both sides, and we're gonna end up with negative x squared plus 4x minus 8, combined like terms. We're gonna end up with negative x squared plus 4x minus 4. Set that equal to 0. Now, it's literally up to you and your preference on which one of these methods you want to use. Now, let's review. Factoring by X method, factoring by grouping does not always work. It only works if you can find the factors to give me the top and add up to the bottom, right? Remember that? Okay. Now, we're going to go on ahead and do by factoring just because I think it's a good review that we can spiral in right now in case you still haven't mastered it. So we're going to use method 1. So in order to do by factoring, A cannot be negative, and I have to make sure that there's not a greatest common factor, right? So I'm going to go on ahead and take out this negative and take it out here to the front. which means on the inside, I'm going to have x squared minus 4x plus 4 equals 0, right? I took the negative out. If I were to redistribute it in, it would give me exactly where I came from. Negative 1 times x squared, negative x squared. Negative 1 times negative 4, positive 4x. Negative 1 times a positive 4, negative 4, okay? All I did was undistribute. I took it out. Now I can work with what's inside the parentheses, so the blue part. So we're going to have our x method. A times c is 4, and at the bottom we have a negative 4, right? If I can fulfill this x, then I know I can factor by what I like to call the x method. So our numbers here would be negative 2 and negative 2. Negative 2 times negative 2 is a positive 4, and negative 2 plus negative 2 is a negative 4. So you should be able to write these in factor form. X minus 2, x minus 2. You should also notice that this is actually a perfect square, by the way, right? Do you remember what perfect squares are? Perfect squares is when you have the exact same thing on each side, right? When you're multiplying. So this happens to be a perfect square. So this is just a side note, okay? So this is actually a perfect square, and this is just me reviewing things that we've learned in the past. So this is a perfect square. Anyway, moving on. When we divide by a, my a here is 1, right? So it's not going to change anything. Because both of these are identical, I know this is only going to have one solution, right? So we're going to use zero product property to find my solutions. So x equals 2. Remember, we're not done. This is just half of my answer. So my solution, because I only got one number out of this, I know it's going to be 2 comma something. How do we find the other half of my answer? Well, you just plug back in. So we're going to grab this number that we just found and plug it back into one of our equations. So I'm going to grab y plus 4x equals 8. And I'm going to plug this 2 inside. So we're going to end up 4 times 2 is 8. So we have y plus 8 equals 8. Subtract 8 from both sides. So you're going to end up with y equals 0. So what does that tell me? The other half of my solution is 0. So this right here is a quadratic, and this is a linear function, right? It's a line. So you have a u and a line, and they're only going to touch one time, and that one time is going to be at 2, 0. So what is that going to look like? Okay, hold on. Let me see if because I had to keep switching back and forth with 6th period, and that got on my nerves. Let me see if I can. Where do I go? Decimals.com, go. Graphing calculator. Okay, so my equations were oops. Oh yeah, don't forget the little negative over here. Not that it matters, right? Because we took it out. So it still didn't, it doesn't change our answer, but yeah, don't forget about that. So we're gonna have negative x squared plus 4x minus 4. So negative x squared minus 4x plus 4. Is that what it was? Or maybe it was the other way around. Oh, it was plus 4x minus 4. My bad. Plus 4x minus 4. Okay. And then the second one was, where was it at? Y plus 4x equals 8. Okay. So, did I do it right? Y plus negative x squared plus 4x. Yeah. So there you go. See, but that, I think I graphed it wrong. I did it right with 6 period. I don't know. Okay, never mind. I'm just gonna have to switch back and forth between sharing my screen because this was too annoying. Okay. Hold on. Okay, so y equals negative x squared plus 4, and then we had y plus 4x equals 8. So then right here, we can see that the only solution that we'll ever share is at 2, 0. So if I zoom out, right, the space down here keeps getting bigger, so they're not gonna cross again. The one I typed in first, I typed it in wrong, sorry. Okay, so here we go. This is the right one. So let's go on ahead and draw a rough sketch of what that would look like on our set of notes. So let me share this again. So stop share. Okay, so that means we have a quadratic function that looks something like this. And then we have a linear function that looks something like that. And they only cross at this ordered pair, which is 2, 0, which is exactly what we just found. Okay. All right, example 2. So what happened with example 2 is that when I wrote down the notes, I accidentally messed up. But I realized that this example is way harder than the original one. So we're gonna do this one instead, just to get y'all's brains going, okay? So it is a little bit more difficult, but I also at the same time wanna talk about if you do have ugly looking answers, how you can use a graphing calculator to your advantage, okay? So I liked this better, even though it was an accident. Okay, so for example 2, first of all, you're gonna notice that you don't have anything isolated, right? And you can see here that we have a quadratic function here, right? Because it's the highest power and only the x is squared, and then the same thing for the second one. So just from looking at it initially, you should kind of see like, okay, I'm dealing with 2 parabolas, okay? So I obviously want to isolate the y on one of them. So I'm gonna go on ahead and do that to the first one. So you're gonna end up with y equals 4x squared minus 16x plus 22. Right? So all I did is I kept the 4x squared on that side and I subtracted the 16x and I added the 22. So now I have one of these isolated for y. The other thing you should have noticed is that on the second one, I have 2 y's. I don't want to plug that in 2 times. So I'm going to go on ahead and simplify this first so that I only have to plug that in 1 time, right? I know that I can combine like terms here. So this is going to end up being 4x squared minus 24x plus 3y. So now I can go on ahead and just substitute that in one time. So you're going to end up with 4x squared minus 24x plus 3. Then you can plug in your expression. 4x squared minus 16x plus 22. And we know that that's going to equal 0. So from here, we're just going to be doing algebra 1, right? So we're going to go on ahead and simplify and distribute. So this is going to give me 12x squared. 16 times 3. 16 times 3 is going to be 48. So we're going to have negative 48x. And 22 times 3 is going to give me a positive 66. And we're going to bring everything else down. 4x squared minus 24x. And this was a positive. From here, we're just going to combine like terms. So 4x squared plus 12x squared is going to give me 16x squared. Then we're going to have negative 24x and a negative 48x. That's going to give me negative 72x. And then my 66, I can just go on ahead and bring that down. And that's going to give me 0. Now, from here, you can obviously see that these are some pretty big numbers. And remember our toolbox, right? This is obviously a quadratic, right? 16x squared minus 72x plus 66. It's standard form. So if I'm going to do by factoring, I already know I'm going to have to factor out a greatest common factor, or you can do by grouping, or you can do it by completing the square, or you can just straight up use the quadratic formula, okay? So after experimenting with 6th period, right? So when you're doing this on your own, if you do not automatically know what method to use, just pick one and see if it works out. And if it doesn't, then go to another one. Or you can just go straight to the quadratic formula, because we know the quadratic formula will always work no matter what, right? So we're going to save me some time because we already did this with 6th period, and you cannot factor this, okay? We found that out the hard way. So we ended up factoring it out, right? And then we realized that there was no factors that I could come up with to multiply to the top and add to the bottom. So we went on ahead and did the quadratic formula, okay? So yes, they're big numbers, but you'll be okay. So let's go on ahead and identify our numbers. A is 16, B is negative 72, and C is going to be a positive 66. If you remember, when we use the quadratic formula, the first thing you will always do is find the discriminant, right? Now, so we're going to go on ahead and find our discriminant first. So that's b squared minus 4ac. So b squared, right? So that's going to be negative 72 squared minus 4 times a times c. So let me put that in the calculator. Negative 72 squared minus 4 times 16 times 66 is 960. So what does that tell me? That tells me it's a positive discriminant. So I already know that I'm going to have 2 real solutions. So we already know that. That is one thing I learned right now from the discriminant. Even if you don't want to use the quadratic formula, you can always use the discriminant whenever you want, just so that you have an idea of how many solutions you're going to have. So I know I'm going to have 2. So then now we're going to go on ahead and use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I already did the discriminant, so I'm just going to go on ahead and plug that in. Right, here's my discriminant. So I already plugged it in. So then now I'm gonna have negative, what is my B? Negative 72 plus or minus my discriminant of 960, or the square root of 960 over 2 times A, and A is 16, so 2 times 16 is 32. So I'm gonna have X is going to equal a positive 72 plus the square root of 960 divided by 32, and you're gonna have X equals 72 minus the square root of 960 divided by 32. So this is what I meant by the numbers got ugly. How many of you want to plug these numbers in back to one of the equations at the top just to find the y value? Any takers? Because I know I do not want to do that, okay? So this is where having technology is helpful, and you kind of sort of, especially if you're taking like the SAT in the future, right? And if they allow you to use calculators, and if your multiple choices look like this, they're only using the calculator isn't going to help you. So you kind of have to like teach yourself to be able to merge both of them into one. So what do I mean by that? As soon as I get here, I'm kind of like annoyed, right? Because I'm like, these are big, huge numbers, okay? So let me go on ahead and share my screen again. So how am I going to use technology to my advantage? Okay, so here's my screen. And I'm going to type these in. So what did we have first? Okay, so my first equation was y plus 16 y plus 16 x minus 22 equals 4x squared. And then my next one was the 4x squared minus 24x plus 3y. Oh, why isn't it letting me graph it? 4x squared minus 24x plus 3y. Oh, there we go. My bad. Okay. Okay, so what do we see here? We see my two my two solutions, right? Does everyone see that? Okay, so this is where you kind of have to like be a problem solver, okay? I know what I have by hand, right? I don't want to plug that in. That's my point right now, okay? So what can we do? I see my solutions, they're right in front of me, but they're decimals. How am I supposed to know if they match? Okay, well, let's type them in. So we're gonna have 72 plus the square root of 960 divided by 32. What is this? I know that my x value is this number right here that I just highlighted. Do I see that here or here? Do we see how this matches my x value right here? So what does that tell me? Did I do this right or wrong? What does that tell me? Do we see how this helps us, right? So I did this by hand. This is what I got. This is the decimal I get out of it. In my graph, I can see that that number exists right here. So what does that tell me? That tells me that my solution, or one of them, is at 3.218, which is this, and 11.936. My other solution is going to be at 1.282. So this, if I plug it in here, but with a minus sign, 1.28175, blah, 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 which is the ordered pair that we have right here. So if you were to plug these two, right, back into the function, you would get some decimal that would be close to 11.936 and 8.064. So am I going to go on ahead and actually do that now? No, I'm not going to do that, okay? But I just want you to see how complicated it can actually get. Am I going to be that mean and give you something this difficult? No, probably not. Not this year. Okay, so from here, let me go on ahead and share the screen of my other thing again. So from here, you would plug back into equation, right? And then your solutions would be at 1.282, 8.064, and then the other one would be at 3.218, 11.936-ish. So a rough draft of what that would look like. We had one parabolic function that looked something like this, and the other one looked something like this. And these were your two solutions, which is what you found. Okay. It's not going to get much harder than that. Okay, so example 3. Remember I said that today's topic is nonlinear systems, right? So here you should notice something. We notice that we have an x squared plus a y squared equals 5. So they're both squared, okay? This is not something that you necessarily have to have memorized, but you have to be able to identify. Anytime your x and your y are both squared, this is actually going to create a circle, okay? So that is what you're always gonna get, is you're gonna get a circle. So this right here is the equation to your circle. So we have an isolated variable, and you have that in here as well, right? So we're still gonna do the same thing, okay? So this is just another example to show you that the process is still the same, but instead of a quadratic for this one initially, once you substitute it in, it's still gonna be a similar process. So you're gonna have x squared plus, instead of y, you're gonna have 3x minus 5 squared equals 5, right? So we substituted that in there. You should be able to see that this is just algebra 1 and you need to simplify the equation. So right here in this part, this is a perfect square, right? This is the same as 3x minus 5 times 3x minus 5. So we're going to use the box method, because from what I know, that's the one y'all like to use the most. So 3 times 3 is 9, x squared. Negative 5 times 3, negative 15x. Negative 5 times 3 is negative 15x. Negative 5 times negative 5 is a positive 25. So we end up with 9x squared, combined like terms, minus 30x plus 25. So this is a positive 9x, so we're going to bring down this x squared and equals 5. So right now, after you use substitution to put these two functions and make one out of them, right, you should notice that what I have now, this right here, should look something similar to what? It looks like a quadratic, right? So let's simplify this even further. So x squared and 9x squared, that's going to give me 10x squared. Then we have minus 30x. Move this over, right? So it's going to be minus 5. So we're going to have plus 20. What does that equal now? 0. So even though at the very beginning, I did not start off with the quadratic function anywhere. I have a circle and I have a line. There's no quadratic there. But once I use my method of substitution and I simplify, I can identify that now at this moment in black, I am dealing with a quadratic function. How do we find the solutions of quadratics? We find them by factoring, grouping, completing the square, or straight up quadratic formula. So here I notice that I can factor out a 10 out of everything. So I'm just going to go on ahead and take that out. So I have 10 times x squared, 10x squared, 10 times negative 3, negative 30, and 10 times 2 is 20. Okay. So I'm going to go on ahead and do this by factoring. So a times c is 2, and my b goes at the bottom. So we have 1 times 2 is 2. If I make them both negative, it's still a positive 2, and I add them together, I get negative 3. So my two factors are going to be x minus 1 and x minus 2. Don't forget about the 10 we took out at the very beginning. And if I divide by a, my a is 1, so it's not going to change anything. So I have my factor form. What do we do now? You're going to use zero product property to find your x-intercepts or your solutions. So x minus 1 equals 0 and x minus 2 equals 0. X equals 1 and x equals a positive 2. Are we done? No, we're not done. So you know you're going to have two solutions, right? You're going to have one where the x is 1 and the other one where your x is 2. So again, think back to example 1, right? When we did example 1, that was a perfect square and it was x minus 2 for both of your factors. So you only had one solution. So you only had one number to plug back in. Here, your factors are different. You have x minus 1 and x minus 2. So you have two separate solutions you're going to plug in for this example. So from here, again, it doesn't matter what you choose. You can choose to plug back into the circle, or you can choose to plug it back into the line. So the first one we're going to do, so you're going to plug in, right? So let's do x equals 1 first. And it doesn't matter which one, but I'm going to do the line, the linear function. So 3x minus 5. So I'm going to plug that in. Y equals 3 times 1 minus 5, which is 3 minus 5. So y equals negative 2. So the other half is going to be negative 2. Then we're going to do the same thing, but for x equals 2. So y equals 3 times 2 minus 5, which is 6 minus 5. So y is equal to 1. So your other half of the solution is 1. And if you were to plug both of these ordered pairs into the circle function, they're both going to give you 5. 1 squared plus negative 2 squared is 5. And same thing for the second ordered pair. 2 squared is 4 plus 1 squared is 1. So 4 plus 1 is 5. So that means, what do we end up with? So your if you were to plug this into decimals, right? Y equals, I had already put the circle in, 3x minus 5. So your picture or your graph is going to look something similar to this. So you're going to have a circle, and you're going to have a linear function that kind of crosses something like that. And your two solutions would be here and here. So this would be your 1, -2 right there. And then this would be your 2, 1. That is what decimals would have drawn for you. And I know that because I'm looking at it right here. Oh, we still have one more example. Okay. You'll deal with circles more when you get into pre-cal. I don't see us dealing with circles very often, besides just, you know, randomly. Okay, so for example 4, start looking at it. What do we see? So what do we see in example 4? While I finish for some of you to write this down. So what type of functions were given to us in example 4? You should see that for example 4, this first one is a quadratic, right? So that way you kind of get a visual of what you're seeing in your head. I know I'm going to have a U shape, and this is linear, right? It's a line. So that means that I'm trying to find where this U is going to cross with the line. That's what I'm looking for, okay? Now, this is an example of when decimals will not work for you, okay? So if I went on ahead and type this in, because I want y'all to see what we are doing, because having a visual always helps. And then we're going to do y equals 2x minus 3. Okay. Oh, that means I have to share. Okay, so I typed them in. This is an example when decimals is not going to work for you. Why? What's happening? Do I see my parabola and my linear function crossing? Are they crossing? No, right? But solutions are there. Your solutions are there. They're just complex. They're imaginary. So you would physically have to do this by hand because decimals is not going to help you at all. Okay, so I wanted to show you that first. Now, I'm also going to emphasize the beautifulness of the discriminant and why I am such a big fan of the discriminant. Okay, this is why I love the discriminant. Okay, but let's get to the method first. Okay, so you can see that we have a y that's isolated. So I'm gonna put my expression in there. So let's go ahead and do that and get it started. So x squared minus 2x minus 3 equals 0. So let's go on ahead and simplify. So we're gonna have x squared minus 2x plus 3 equals 0. Here, I can identify that this is mimicking a quadratic function, right? So I'm going to use my toolbox for factoring, my toolbox for finding solutions. And again, you can do it however you want. You can do it by factoring, blah, 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 blah. But this is I'm going to emphasize why I like using the discriminant sometimes first. I know how to find the discriminant, right? The discriminant is always going to be the b squared minus 4ac. Why is that important? If you do this first, you can tell yourself, will Desmos even be able to help me? So my b squared, that's negative 2 squared minus 4 times 1 times 3. So we have 4 minus 4 times 3, which is really just 12. 4 minus 12 is equal to negative 8. Right here, without you having to graph it on Desmos, you can also tell yourself, Desmos is not going to help me because this is a negative discriminant. So that means that we have no real solutions, which means that my answer is going to be complex numbers. Which means it's going to be an A plus BI form. That's what that means, imaginary numbers. Remember that? We did that last time. We're going to go on ahead and find those solutions. So if you have complex numbers, you have to do either by completing the square or you have to do it using the quadratic formula. Factoring will not work here. Why will it not work? That means you would have 3 there and negative 2 there. This is a negative 2, which means they both, so this is a positive 3, so they both have to be positive or they both have to be negative, right? There is no combination you can do with 1 and 3 that's going to give you a negative 2 and keep your positive 3, right? So you have 1 and 3, 1 and 3, 1 and 3, 1 and 3. You can either have positive, positive, negative, negative, positive, negative, or negative, positive, right? This is positive 2. This is negative 2. This is negative 4. And this would be, I'm not even thinking anymore, positive 4, right? The only one that works is this one, but that's a positive and a negative. Can I have that? No. They both have to be positive or they both have to be negative. This is not factorable, which is the reason why we have to use the quadratic formula, okay? I just wanted to like kind of touch base on that. You didn't have to write that down. Well, you know what? Let me leave it in case you did. Okay. So putting this off to the side. Oh, crap. Sorry. Okay, so leaving this off to the side, right? This is the reason why we can't factor. Okay, so we're gonna go on ahead and use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I already know what my discriminant is because I already found it. So I'm gonna plug that in. I already know what that is. That's gonna be in there. So I'm gonna deal with that later. Let me go on ahead and plug everything else in so I can see what I have. So x equals negative, my b is a negative 2. So I'm going to put negative 2 plus or minus the square root of negative 8. I already have that. And 2 times a is just 2. My a is 1, so I have 2. So let me simplify that even further. So I'm going to have x equals a positive 2 plus or minus the square root of negative 8 divided by 2. We talked about having that negative discriminant, right? That was our complex numbers day. So I'm going to graph my discriminant of negative 8 and I'm going to simplify it. So I'm going to break it down again in case y'all forgot how to do this, right? So we know that inside this root, this is negative 1 times 8, which means I can break it down even more to negative 1 times 8. This is I, and this can be broken down to the square root of 2 times 4, which is the same as square root of 2 times the square root of 4. Well, what's the square root of 4? 2. So we have 2, the square root of 2. So negative 8, the square root of that is equal to 2 square root of 2i. So we're going to have x equals 2 plus 2 square root of 2i divided by 2. And we're going to have I don't want to squeeze it in. Okay, 2 minus 2 square root of 2i over 2. You should see that there's a lot of 2's, right? So that should kind of trigger something in your brain like, oh, I can probably reduce this, right? So 2 divided by 2 is 1. So x equals 1 plus, and then, so that's me doing that part, right? And then this part right here, 2 divided by 2 is 1. Square root of 2i. Same thing here. So you're going to have x equals 1 minus square root of 2i. Right? Because I mean, I guess you could put the 1, but you don't need the 1 anymore. There we go. Okay, so what do we have so far? We know that we're going to have solutions at 2 spots. One of them is going to be at 1 plus square root of 2i, comma something. And the other one is going to be at 1 minus square root of 2i, comma something. How are we going to find the second one? Well, you already know. You're going to plug in. So I'm going to use my linear function part of this, right? So I'm going to plug into y equals 2x minus 3. That's where I'm going to plug it into. So you're going to have y equals 2 times your first x minus 3. My first one is 1 plus square root of 2 times I. So y equals 2 plus 2 square root of 2i minus 3. Combine like terms. So y equals negative 1 plus 2 square root of 2i. So negative 1 plus 2 square root of 2i. And then we're going to do it again. So we're going to have y equals 2 times 1 minus square root of 2i. Distribute. You're going to end up with y equals 2 minus 2 square root of 2i minus 3. Combine like terms, y equals negative 1 minus 2 square root of 2i. So negative 1 minus 2 square root of 2i. So these are your solutions in complex form. They're imaginary, right? So this is what the decimals gave me. We had a quadratic function here, and I had a linear function, oops, that looks something like this. These were never going to intersect. So your solutions were imaginary, they're complex numbers. So those are your answers. 1 plus square root of 2i at negative 1 plus 2 square root of 2i. And your other solution is at 1 minus square root of 2i, negative 1 minus 2 square root of 2i.